Okay, so we started day 9, graphing rational functions. We have done everything in terms of graphing rational functions. There's nothing new. At this point, over the next few days of notes, we will just be doing more examples. Some examples will be like example number 1 that will focus on a specific idea. Some will be like number 2 where it just says graph and you're going to need to remember everything you need to find. Okay, so let's start with example number 1. We are asked specifically about the horizontal asymptote. The horizontal asymptote is the y equals 1, obviously the one that goes horizontally. That's the one where you need to compare the degrees in the numerator and denominator. In this case, same degree, x squared and x squared. The deal with the same degree, when numerator and denominator have the same degree, you divide the lead coefficients. So we have 5x squared, 1x squared. So our horizontal asymptote is at y equals 5. It has to be written y equals 5. Just plain old 5 I will not accept. Y equals 5 because it's a line. So that's part A. Part B, we want to know, is the graph going to cross the horizontal asymptote? And where it does. The way you approach that one, if you remember, you are going to set the horizontal asymptote equal to your equation. So our horizontal asymptote is 5. We're going to set that equal to the whole equation. So 5x squared plus 2x minus 6 over x squared minus 7x plus 3. And this is what you're going to solve. That 5 that's on the left side, I'm going to write that as 5 over 1. The reason I do that is so that I can cross multiply. I will then end up with 5 times x squared minus 7x plus 3. And that'll be equal to 1 times 5x squared plus 2x minus 6. This is what we need to solve. Let me be very clear, listen to this. Sometimes there will be no solution. So sometimes you will go to solve this and you'll get a false statement, like 0 equals 4. That tells us our graph does not cross the horizontal asymptote. Okay, so what I'm going to do now is I'm going to distribute on both sides. Left side, I'm going to distribute that 5. So we get 5x squared minus 35x plus 15. On the right side, I'm just distributing a 1. So I get 5x squared plus 2x minus 6. What is super nice is that those x squareds cancel out. The x squareds cancel out. So now I just need to get the x's alone, the numbers, or the x's together, the numbers together. So what I'm going to do is I'm going to add 35x to the right side. And when I do, on the right side of the equation, I get 37x. What I'm also going to do is I'm going to move that negative 6 to the left side. And then 15 add 6 will give me 21. So when I divide by 37, I get 21 over 37. So what that tells us is that we will cross the horizontal asymptote at the point 21 over 37, comma. Don't put extra work in to find y. We already know what y is. Y is the horizontal asymptote. So the point is 21 over 37, comma, 5. Both of those steps you will always need to do when you're graphing. So that is the first thing we needed to review, was finding the horizontal asymptote. Questions? Okay. Bless you. Example 2 is a graphing example. We are going to write down everything that you need to find. Before we do that, the first thing you always have to do, no matter what, is factor. So that's what we're going to do right now, is we're going to factor. The numerator does not factor. The denominator, we are looking for two numbers that multiply to 40 and add to negative 13. Ooh. And that is 8 and 5, or negative 8 and negative 5. So we get x minus 5 and x minus 8. At this point, we would cancel out anything that we can cancel out, which is nothing. Okay, please make this list right now. We need to find wholes, intercepts, both x and y, and asymptotes, horizontal and vertical. You're always going to have to find all three of those. Doesn't matter the order you find them in. The only order that matters is that you factor first. That is the order that I go in. So first, I'm going to find wholes. Wholes comes from anything that cancels out. We don't have anything that cancels out, so there are no wholes. For our x-intercept, that means that y is 0. So we will take our equation and make y 0. I'm going to write that 0 as 0 over 1, so I can cross multiply. 0 times anything gives us 0. And then 1 times x plus 5 just gives us x plus 5. When we solve, we get x equals negative 5. So that tells us that our x-intercept is the point negative 5, 0. I like to graph information as I find it, so I'm going to put that point on the graph. So negative 5, 0. The other thing that I want us to know here, that x plus 5 is to the first power. So what that tells us, because we have an odd power, is that this intercept is going to cross. It's not going to bounce. So we can't graph that now, but we're going to have to remember when we do graph, we're going to cross, we're not going to bounce. That is one of the intercepts. The y-intercept is when x is 0. So we are going to use our equation and plug in a 0 for x. In the numerator, we're going to get 0 plus 5. So that's just 5. In the denominator, 0 minus 5 is negative 5. 0 minus 8 is negative 8. So this is 5 over, not 50, sorry, 5 over 40. Which simplifies to 1/8. So our y-intercept then is the point 0, 1/8. This one, we do not need to be concerned about bouncing or crossing. 0, 1/8 is like right here, let's say. Okay, questions so far? Okay, third and last step is the asymptotes. The vertical asymptote comes when you set the denominator equal to 0. So in this case, x minus 5 times x minus 8 equals 0. That gives us values of 5 and 8. So we have two vertical asymptotes in this case. X equals 5 is right here. And x equals 8 is right here. horizontal asymptote comes when you compare the degrees. In the numerator, we have x to the first. In the denominator, if we would multiply this out, we would have x squared. So they're not the same. In the case where the numerator is smaller than the denominator, like we have here, here we have x to the first compared to x squared. That tells us that our horizontal asymptote is at y equals 0. So we are going to graph that. Last step before we finish the graph. We do need to check, do we cross the horizontal asymptote? So we will set that horizontal asymptote equal to our equation. If we are paying attention, we should notice we already solved this equation. Where did we solve this? X-intercept, but yes. Yeah, this already came up here. We already did that. Don't solve it again then. You already know what the answer is going to be. We will cross at the point -5, 0. What that also tells us, though, is we're crossing nowhere else. Only at -5, 0. Okay. Ooh. Okay, I'm going to move that off to the side because I want to get back to my graph. Okay, there's one other thing I want to tell us before we finish the graph. When you find those horizontal asymptotes that relate to the denominator, you have to pay attention to their powers. So this one has a power of 1 and a power of 1. What that odd power means is that our graph is going to go in different directions. So what I like to do is I like to write that above the asymptote. So we are going to go different directions here, and we are going to go different directions here. Okay, and now we are ready to fill in. Like I said before, you are always going to start where you have points. Keeping in mind, we need to hug the asymptotes. So this point right here, the y-intercept, if I start there, I have two options. I can go up and hug the asymptote, or I can go down and hug the asymptote. Now we know we are not going to cross the horizontal asymptote. Okay, so like I said, we are not going to cross the horizontal asymptote. The only place we can cross it is right here. So our graph can't go down, it has to go up. So that's what we're going to start with.
Can it go down again?
Because it cannot cross the horizontal asymptote. The only place we can cross is that point we found. So then we know we're going to come down and we're going to hit this point. So I'm going to do that. We're going to come down and we're going to hit the point. So then the question is, it's going to hug the horizontal asymptote. Is it going to hug below or is it going to hug above? If we go down and we cross down, we can't cross back up. We also know that this is going to cross and not bounce. We figured that out before. So that means that our graph has to come down and hug the asymptote, but it doesn't cross back up again. So that is the first part of the graph. There will be two more parts. One in the middle, one to the right. The part in the middle. If I look at this asymptote at x equals 5, it says I need to go in different directions. The graph can't go up then. It can't match. It has to go in a different direction. So on this other side of x equals 5, I have to go down like this. I know I'm going to hug the other asymptote. So the question is, am I going to hug above or am I going to hug below? Well, I can't cross the horizontal asymptote. This is the only place I can. So it isn't an option to go up. The only option is to go back down. So this one will go like that. And then I have to figure out the last part of the graph. Again, at x equals 8, we should be going in different directions. That tells us we can't be going down. We can't be going down, we have to be going up. So that's gonna go like this. And then it'll come down and hug the asymptote again, the horizontal, but not cross it. This is the thought process you need to go through when you are graphing. Jackson?
Can you go over like the middle one again? Like,
Sure.
Can you kind of do the graph of it?
Yeah. Okay, so for the middle one, first I know that this asymptote, because it's an odd degree, on the two sides I need to be going different directions.
Yeah.
So if this graph is going up, on the other side I have to be going down.
Okay.
Was that it?
Yeah, and then you can't go up because then you would cross the.
Yeah,
All right.
exactly. Okay.
When it's the vertical asymptote, what is the t e n equals 0?
Denominator.
Denominator.
I just got lazy and didn't want to write out the whole word.
Right.
This is the steps you need to go through. I recorded both days 9 and 10, and I will put this on YouTube so that you can go through this example while you are graphing. I believe your homework has 2 graphs on it. There is one last thing I want to show you real quick. This isn't on your notes, so just write it down somewhere. Okay, last thing I want to talk about real quick is, let's say you have something like this. I'm going to just give you some pieces of information real quick. We're not going to find a lot of stuff. I'm just going to tell it to you. I'm going to tell you that the vertical asymptote is at x equals 2. The horizontal asymptote is at y equals 0. There are no x-intercepts. And the y-intercept is 0, 1/4. There's a reason I'm showing this to you. It's not something we've seen before. So we're going to graph this real quick. So here is that vertical asymptote. Here is that horizontal asymptote. Here is that y-intercept. Okay. Last thing I do need to tell you, does this cross the horizontal asymptote? No, it doesn't. So all of this information we could find using the exact same steps that we did. I just want to give it to you because all I want to focus on is the graphing part. Okay, so we cannot cross the horizontal asymptote. From this point then, we have to hug the horizontal and hug the vertical. So that's what we're going to do. We would hug the horizontal and we would hug the vertical. Here is what I want to show you. This vertical asymptote, which again comes from the denominator, this is the only one we've seen where the degree is even. That makes a big difference. If the degree is even, what that tells us is our 2 branches are going to go the same direction. Not different. They're going to go the same direction. So if the blue one is already going up, on the other side, I have to be going up also. And then we know that we don't cross the horizontal asymptote, so it would come down like that.
That was because they were even?
Yes. So if the power is even on both sides of the asymptote, we should approach the same value. Or not the same value, but go the same direction.